Hello world, I'm going to show you AP Calculus BC Section 1 Part A. So it will takes 55 minutes to take this exam and there are 28 questions. I know that quite busy while we solving that we can get sometimes run out of time, but don't worry about that. After some practice, then you can overcome this easily. So believe yourself. Let's deep dive into these problems. Number one, there are function y equal to cube sine x. So here this symbol, it represents please find out the derivative of these functions. Okay, right, then y equal to sine cube x. So its derivative 3 and 2. This is not the end. We have to do some more. The sine x, that's an in function. So when you do differentiate something, then you have to differentiate in function and make this one as like this. You have to use a multiplication. That's a chain rules. So this is a result of complete differentiation. So now we have a derivative here. So this is going to be a right answer. Number two, the position of a particle moving in the xy plane. You know what is xy plane. There is an x-axis and y-axis, and we can make a xy plane here. And then there are parametric equations. This is for x and this is for y. And which of the following points is the particle at rest? What does that mean? The particle at rest, what is this? Look here. When the particle is at rest, that means their speed or velocity should be 0. So when the velocity is equal to 0, then x velocity and velocity for y, these two should be 0 in simultaneously. So x prime 3, 2 square and 60, and y prime, the derivative of y, that's going to be 12 and 60. So I'd like to make this as 0 because I have to find out the particle at rest. So 3t and 2 minus t equal to 0 and 6 2 minus t equal to 0. So the particle at the direction of x, t equals 0 and 2, there are two moments take a rest in x direction, and these are when time t equal to the y direction movement take a rest at that time. So I think the t equal to makes these both these two the 0 simultaneously. So I like to choose that one, t equal to. Alright, then we're gonna go for the next step. So x2, this is the position of x direction. So -4. And about y equal, when y equal 2, 12, 2 and 3, 4, 24 and 12, that's gonna be 12. So I think the x-axis -4, sorry about that, this color, I'll give you more bright one. So -4 and 12, that's gonna be a proper answer, I think, for this problem. Here we have some kind of graph. I will try to color here. This one is a graph and this one is a part of graph. And I think this is a point discontinuous. So its x-axis is 2. Its x-coordinate is 2. Right, then the graph of f is shown above for from 0 to 4. What is the value of the integration from 0 to 4 fx dx? You know the meaning of this integration, that's the area below the graph and above the x-axis. And when the area is above the x, then it has a positive sign, and when the area is under the graph, under the x-axis, then it has a negative sign. Negative sign. For an example, if you have a 5 area and area 4, then you have to use a negative sign. So negative 4. That's not a complete area. It's just a value of integration. The value of integration not always same to area. Area should have a plus sign, positive sign. So if the area has minus sign, negative sign, then that's not a real area. If you want to make this one, then you have to use an absolute value, then please make 4, then this is an area, but this one is not an area, but value of integrations. Sometimes value of integration and area, sometimes they are not same each other, but sometimes are same. Alright, please keep this perception in your mind, and then let's go here. So I'd like to get this area, the triangle and rectangle. It's not hard to us to get this one. So here 2 and 1, 2, 3, 4, 2, 4, and the area of here, that's gonna be 6. And look here, 1, 2, and 1, 2, 3. This area is 6, but it is below the x-axis. We would like to we try to get an integration, so we have to use minus 6. So 6 and negative 6, it gives us 0. So 0 gonna be a right answer here. So please don't confuse area and value of integration. Sometimes are different. Okay. Let's go for number 4. Which of the following integrals give the length of curve? Here the important word, the length of curve. You have to know about the formula, how to find the length of curve. I will show you. 1 plus dy dx square and square root and integration from a to b, then it will give you the length of curve. So this is here is a derivative of a function. So you have to find that. Oh, here. So y equal to ln x, this is a given function, so I like to find out its derivative now. Then when I finish this, I will get something can be in this, can be in here. Derivative of natural logarithm of x is 1 over x, so 1 plus x squared and square root to dx can be here, and the intervals of this integration from 1 to 2, so 1 and 2 can be here. So I think I can make it. Here number 5, the Maclaurin series for the function f is given by right here. And what is the value of this function? So when we plug in 3 to the x. Alright, sometimes it is very hard to infer the original function of this Maclaurin series. So now I'm going to use the different way to get these functions. Do you know the geometric series? Geometric series. When we add up all these numbers, infinitely many geometric series especially, then there is a formula. It looks like this. R represent the ratio, and A the first term. A represent a first term. So look here. This can be a ratio. If we can make the Maclaurin series, and I think this should be converged. This is my proposition when I solving this problem. So please keep this one in your mind. It's very important. So then I can make this. So I will plug in my ratio here, and first term that's gonna be 1, so 1 plus x over 4 and 1, so x over I'm sorry about that, 4 plus x 4 and 1, so 4 and x plus 4, that's gonna be an answer for this question. So when I plug in 3 to the x position, and 4 over 7 gonna be answer for these questions. So please keep this on your mind. I used some formula, infinitely many geometric series sum. Let's try this integration. When we are solving this integration, we're going to use the method substitutions. Alright, this is quite a lot tips for solving these problems. So u equal to x squared minus 3, then we have to differentiate each side, and dx equal to 1 over 2x du. I'd like to call this one is the substitution box. If you get in this box, when you get out from this box, then you can change this x equal u to the power of 5 and 1 over 2x du. And your interval should be changed also. So the -1 and 4, that's the value for x. So when you have -1 in the x, then your u value, that's going to be -2. And when you have 4 for the x, then 16 minus 3 is 13. So u value, that's going to be 13. So 13 and -2, that's going to be an interval for u. Yeah, so we did a complete substitution, and we can reduce x and -2 and 13, u to the power of u du. So we can integrate this one easily. So 1 over 6 and u6 and -2 and 13. So it's gonna be 13 6 minus -2 to the power of 6. But we don't need to do this. We have to get just the integration representation. So I think the number B is for that's the proper one for this problem. Yeah, we have the implicit function. I'm going to show you what is implicit function and explicit function briefly. Explicit function means explicit. It has the form like this: y equals something, y equals something, y equals something. That's so almost every function we familiar with. That's our explicit functions. It has the form like this way. But implicit function, it is quite different from this one. X squared y cubed plus 5 equals 0, or xy plus x cubed and y plus 1 equals 0, or x squared y squared equal to 7, like this. All these things not starting from y equal. The y, it looks like hide somewhere in the equations. Yeah, so we call that this kind of things implicit functions. Then the way of the derivative, it's a different from the explicit, right? So please come back here, and arc sine x and ln y here. So arc sine x, it looks like its derivative is this one, and the ln y, its derivative is this. That's quite easy ones. So if you want to make a dx dy, then you have to multiply y to both sides. Then you are gonna get a y over square root 1 minus x squared and dx dy here. All right. Some students ask me why this dx dy only beside the y, so I will show you why that kind of thing should be happened. Here is another one. Look here, y that remind us there's some kind of function, right? So I will remove the y from here for to explain something to you here. If you have this one, so you have when you have to differentiate this kind of things, and then you act like this, and then this is not the end. The inside function you have to derive it once more and attach it like this way. This is a chain rule, okay? So y to the power of 5, it reminds us it's something like x4, x to the 4, and x to the 3. So if you differentiate this one like this, then this is not the end. You have to do something more, right? Yeah, right. Differentiate the y. Okay? Yeah, these two almost the same things. So when we differentiate y, then we have to attach these things, multiply dx dy. So this is the reason why we have like this after the differentiate. All right, so the result, we already have a result here, that's an A, and I explained why we have to have a dx dy after differentiate y. Yeah, here's the tables. So let's read together. Number 8, a tank contains 50 liters of oil at time t equal 4 hours. Oil is being pumped into the tank at a rate of t, and where t is measured in liter per hour, and t is measured in hour. Yeah, all right, t is an hour, that's a time, and RT, that's gonna be the liter per hour. And then the RT are given in the table above. Here we have a table that shows us an RT and T. RT is a red one, so I will change the color as a red. So that's represent an RT. Alright, then I'm using the Riemann sum with the 3 subinterval n data from the table. What is the approximation of the number of liters of oil that are in the tank at time t equal to 15 hours? Let me check. The Riemann sum is has a perception like this. If you are trying to add up all these areas, then you can make an approximation, so you can get a area below the curve approximately. Alright, so there are 3 subintervals. That means here 1, 2, 3. The difference 4 and 7, that's the first subinterval, and difference 7 and 12, that's the second subinterval, and 12 and 15, there are third subinterval. So there are 3 subintervals. And the Riemann sum have to get the area of a rectangle, so you have to imagine there are some kind of rectangles. But you have to use right Riemann sum. This example, this show you left Riemann sum, because the left of the rectangle, that's the height. If you want to make a right Riemann sum, then you have to think like this. The right side of a rectangle, that's gonna be a height of these rectangles. Does it make sense? Alright, so I'm gonna use this right as a height. If there is a rectangle, then I will use the right side, the number, as a height. Also, if there is a rectangle, and I will use the right side as a height. So I can do this. The base 3, and here base 5, and here base 3. So 3 and 6.2, and 5 and 5.9, and 3 and 5.6. So when I add up all this number, then I think I got a right Riemann sum with the 3 subintervals. This is it. So finally I get 64.9, and here we are.